All right then, welcome to this talk on building first-class REST APIs with Symfony. Firstly, a very quick word on who I am. That is a very ugly photo of me, and it's incredibly large when it goes up there. My name is Michael Cullum. My Twitter handle is at the bottom of the slide. If any of you wish to tweet feedback, comments, suggestions, thoughts, or even abuse, I am completely defenseless for the next 40 minutes up on this stage, so now is your opportunity to do so. I work for a company called Sam Knows. We're based in London, and we do lots of buzzwordy stuff like machine learning, big data. But we basically measure internet performance for ISPs like sort of BT, Virgin, and also regulators like Ofcom. I'm part of the Symfony core team. I'm the security lead, so if any of you have anything to do with security vulnerabilities in Symfony, or you discover that, then that would be coming through to me. I'm also part of the core committee of the PHP Fig, which is a kind of standards group for PHP. And I'm also on the management team of PHP BB, which is a forum software that you will probably use 10 years ago, where your sites had loads of spam, maybe got hacked twice a week. It's a lot better now, but it's still going, so 25 million installations. So if you want to talk to me about any of those, we're hiring at Sam Knows, by the way, come chat to me afterwards. So APIs, what we're here to talk about. So when I was thinking about this talk, I was thinking, okay, we want to talk about REST APIs, and what actually is REST? Because you hear a lot of people sort of saying, oh, I have a REST API, or I have a REST-ish API, or a RESTful API, or and which of these APIs are actually REST APIs? Hint, not most of them. But possibly, if you've been to another talk about REST APIs, probably more than they actually said in that talk. So REST was, the initial idea for it came out in 2000, it's 18 years ago now. REST is now an adult this year. Happy birthday, REST. By a guy called Roy Fielding. And he produced it as part of his doctoral thesis. And it was part of a much wider thesis on sort of software architecture and APIs in general. And does anyone know what REST actually stands for? Just like a show of hands, I'm curious. OK, maybe 15 people in the room. It stands for representational state transfer. So it's all about how you're representing your data, the current state, and that's what you're transferring. You're transferring essentially, if you do a memory dump of your laptop, if any of you do that kind of thing, I don't know why you would, then essentially what you're grabbing is the state, and then you want to transfer it. So that's essentially what a REST API does, is it grabs a copy of the current state, and it transfers it. And that's REST. So I did the thrillingly exciting task when preparing for this talk of reading this doctoral thesis, which I can tell you. So I don't know if any of you have spent much time reading like computer science theses on various things that we do on a daily basis. They're not very interesting. I love computer science. I'm quite mathsy. I like the theory. But honestly, when you read these things, they're quite dull. And they're very long. But essentially, there were a series of principles as to what actually makes a REST API. So I'm not going to say, oh, you need to do this, 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 and this to make it a REST API, sort of completely random and very specific things. We'll talk about the principles. So the first principle, and it has to have all of these principles except for the one optional one, to be a REST API, or a RESTful API. Otherwise, it's REST-ish or just RPC, or just an API. Uniform interface. So essentially, and you can break this one down into a few sort of small categories. This is one he talks the most about, and it's probably the most important part of a REST API. First of all, it needs to be resource-based. So you're not just grabbing your database and dumping it out, like I talked earlier in state. You actually need to be talking about very specific resources. Everything is a resource. So you might have a user might have an address, they might have multiple groups. All of these are resources. You can't just dump out useless data from your database. There's also, and I will read this from a couple of these in my speaker notes because they're quite wordy, manipulation of resources through representation. So what that basically means is that for you to be able to manipulate an object through a put or an update or something like that, you need to have all of the information necessary to be able to do that. So you need to know what all the fields are, for example. Now, generally, in the case of like a get and then an update, you would do this by running a get before you run your post or your put. And the reason that you're doing that is essentially, and the fields should match. You shouldn't have sort of inconsistencies where you've got address underscore line underscore 1, and then when you're doing a patch, for example, you then take out all of those underscores. That's not RESTful. The next one is self-descriptive messages, which basically means specify your media. Use MIME types, which I believe Fabian mentioned in the keynote earlier on. Say that you want JSON. Say that you want XML. And then when you're giving XML and JSON, say, I'm giving you XML, I'm giving you JSON, I'm giving you HTML. That's really important. And then finally, which is probably the one I think people probably talk about most when they talk about is an API RESTful or not, hypermedia as the engine of application state, or also known as hate OAS. This is a few different things. So it's all about being able to use hypermedia, which basically means link to stuff. If you reference a resource and you're not including all of it in your actual content body, then you should link to that resource. You should say, here is a link, an API link to those groups or to that country. You should have all of your data, this is a separate point, you should have all of your data should be contained within your URI, your headers, and your body. You can't use anything else. And in the same way that when you do an HTTP response, it should all be in your status code, in your response headers, and again in your body of your message. So that's essentially what it's talking about there, but particularly the links part, which a lot of people kind of leave out when they build APIs, and they still call them REST-ish. And it kind of makes sense. So the next kind of principle that he states is it has to be stateless. Basically, don't have any sessions. Sessions, they can't exist. So WebSockets or anything like that, everything that you need to complete a request needs to be inside that one HTTP request. So for example, authentication, you need to pass that in a header. You can't rely on them having logged in like a previous request, for example. Cacheable. So it needs to be able to be implicitly or explicitly stating that you can cache something or you can't cache something. Generally, the idea is that it should be cacheable where possible. And if not, if the entire thing isn't cacheable, you should specify which parts are. Otherwise, basically, it's just about being able to make sure you're sending your cache control headers, to be honest. Client server. Who develops APIs where you define a spec, and then the backend team go and work on the API, and then the front-end team or mobile teams or whatever go and work on their part, and then you come back together at the end? But with the spec in between, spec first. Yeah, quite a few of you. So that's really important, and that's what this is talking about. The client and the server should be entirely separate. The client shouldn't know anything about data storage. It shouldn't care. It shouldn't know about your database. It should also be able to be dependent completely independently of your server. In the same way, your server shouldn't really care about user interfaces or anything like that, or even like login state, for example. You should be able to have it as a layered system. This one is probably not quite as helpful. Basically, you should be able to have proxies in the middle, which might talk to another API. You need to not rely on whatever you're talking to as a server talking directly to the database. And finally, code on demand. This one's really odd. And if anyone actually has anything to do with this, I'm curious here. Basically, servers can temporarily extend clients' functionality by basically sending them stuff. And this is more common with Java applets, or if you want to do something like inject client-side JavaScript. It's very odd. I've never seen a use for it. And it is listed as the optional principle for a REST API. All of the others on there, if you don't have all of them, it's not a REST API. If you haven't got cache control headers, your API is not RESTful. Interesting. So what? Babbling on a little bit. Let's jump into some of these things. First of all, you need to make sure that you're using HTTP well. And there are a whole bunch of different parts to HTTP. But quite often, we only really interact with gets until we're talking about APIs, and then it gets a bit more complicated. So first of all, verbs. Your verbs are really important. You have get, you have post, you have put, you have patch, you have delete, you have update. And you have a whole bunch, there are a few others as well, but they're sort of less common. Now, one of the reasons that they're important is that it actually informs crawlers or bots and stuff as to what you're actually the action you're trying to complete. And it allows you to just have the resource as the URI, and this is saying what you want to do to it. I stole this from a talk that a friend of mine, Phil Sturgeon, did as an example on why HTTP verbs are really important. Essentially, what happened is, for those of you that maybe can't read that at the back, my favorite WTF story is using a get verb to delete resources, which was interesting when Google crawled the API. Yeah, that's also why you don't use auto-incrementing version IDs. Use the right HTTP verbs. I'm not going to go into too much detail there because I hope most of you kind of already aware of that. Same way, HTTP response codes. Use them correctly. Who uses these? Great. Who uses some that aren't up on there? OK, about half of you. So these are, I've come up with some funner names for them, or what they actually mean. You've got sort of 200, everything's OK. 400, you made a mistake. 500, I made the mistake. 405, fix your HTTP verbs. You'll use that. It's in the Symfony framework. 404, 403, 401, same, all in Symfony. You should also be using these ones. 201. So instead of saying a 200, everything's OK, if you've just created a resource, if someone's done created a user, then you should say, OK, I've created that, instead of just everything's OK. If you're doing something in the background, like sending an email, or you're going to create it as an async process, then send a 202. 422, unprocessable entity, validation errors. Most people just use a standard 400, which just says you made a mistake. It doesn't tell them what the mistake was. The mistake could have been that they weren't authenticated. 403 and 401, they mean different things. One means you need to log in. One means that you really shouldn't be here and go away. 410, gone. That means that whatever resource you're trying to access, it did exist one day, but now it's been deleted or suspended or banned. 429, rate limiting. There is and this one's a lot more recent than a lot of others. There is actually an HTTP response code for rate limiting. You shouldn't just throw a 500 or whatever kind of thing you feel of. And then 503. This is probably more something for your web server, but that's saying, hey, I can't connect to the API, or perhaps I can't connect to the database. So you can do this in Symfony. It's super simple, right? This is all you do. Yeah? Who does this? Great. Who doesn't do this? OK, trick question. Don't do this. Do this. In the response class, there is actually a whole series of different constants and I've actually had to trim it down just so that some of them could fit on the slide. It actually went on for sort of 3 or 4 slides worth. All of these are defined as constants. And this is a lot easier to use. It's not a magic number. It's there, use it, it's nice. It also means that you can immediately see in your application where is using this particular constant. Errors. Let's talk about errors. So errors in your APIs, and one thing that I'll kind of go through, and I'm not going to talk about in this talk, but that's about having sort of a consistent format for your API and sort of being able to document it and maybe having, so that Sam knows what we do is, and which is what a lot of this stuff is based on. We'll have code, and then we'll have data and maybe message and maybe other sort of top-level fields. But essentially, we always have this code field, which kind of says what's going on. In addition, to maybe we want to give more detail than the HTTP response numerical code might want to give. So you want to return an error code, and you want to do it in JSON if you're being requested JSON, or you want to give it back in XML if you're being given XML. And you want it in the format of all of the rest of your API. And maybe that's not what Symfony matches. If you are correctly using your accept headers and you're sending something to a Symfony application, you say, I want JSON, it will give you a JSON error back. It won't give you an HTML one. But it just might not be in the right format. So we want to change how errors are handled in Symfony. So what's the obvious way of doing this? Yay, an event, right? Yeah? Yeah? And you can do it, and this is a perfectly valid thing to do. What we're doing here is basically on kernel exception for an exception. We create a brand new JSON response, unknown error, get the exception, and then we set the response to it. Simples. This isn't a great way to do it. It works, but there's a better way, and that's defining an exception controller to override the default in Symfony. So here, we can see exception controller, and this is the method that really matters. It's show action. Request, flatten exception, and debug logger interface. So the things you pass in, and then it will just return a response. So what might you put in here? So here we're just looking at the exception and we're getting the status code so that we can get our HTTP status code. Hopefully when you're throwing the exceptions later down, it will have already set that correctly using constants, not magic numbers. Then what we do is, I'm just going to grab the body for now. I'll jump into that in a separate slide. I return a JSON response. I set sort of the headers to say what I'm setting, and then I just return the response. Simples. Obviously, if you're handling more than one format, so you might be handling JSON, XML, et cetera, this would become a bit more complicated. So actually getting the error. So again, at Sam Knows, I mentioned that we have a code field and we have a message field. So here what we do is we get the error, which is that method we were calling to try and get the body of the response that we care about. We check if it's a validation error, a validation exception, which we'll talk about in a bit. And if we do, we sort of just add in the errors. And then we throw this error together, this error message together if we've got debug stuff in there and that extra information. You can put whatever you like in there. It's up to you how your API is formatted, right? But the fact is that you should be making sure your errors are being correctly formatted by Symfony into the format that you're documenting in your API. And then here, actually, I'm just referencing the sort of error map up here, which I'm just using to refer to exception classes and then different error messages. If not, it just defaults to unknown error. OK, so that's errors. DTOs. Who uses DTOs? Great. Who loves DTOs? So DTO all the things. So I like DTOs. And when you're submitting data on a REST API, it's a bit of a pain in the ass, let's be honest. Because you've either got to go into the content of the body and you've got to extract out the fields and you've got to do normalization, serialization. It just sounds complicated, right? But there's actually a really nice way that you can clean up, particularly your controllers. Your controller shouldn't be more than 5 lines, realistically, of code. Your controller should be quite small. And we'll look at a controller later, I believe, actually. So the param converter is your friend. Who uses the param converter? OK. Who uses it just to say, OK, I'm having like a blog post ID, and you use that to kind of put into your controller, just for that. So those simple, directly grabbing an entity. Who uses it for that? OK. So it turns out with param converter, what you can actually do is you can specify things that go into your controller's method signature. And you can create custom objects, and it can automatically populate them for you before you even get into your controller. So this is a method in a controller, post addresses action. So we're creating an address. And I've got this thing here, an address create DTO. I didn't actually say what DTOs are. DTOs, data transfer objects. They're essentially a class or an object that just contains a variety of fields for the simple purpose of being able to transfer data around in your application, but using properties instead of like an array with keys and values. It's a good way to make sure that you know exactly what data is in there, what data isn't. You can use getters and setters and that kind of stuff. So essentially, when I hit my controller, I already have my DTO populated from whatever JSON I'm being given. That's great. I don't need to have all of this junk in my controller. And then this is sort of just a magic method that I created in the application I took this from. Map and persist basically grabs this DTO, it maps it into, this would be the new entity that I'm trying to map it into. there'll be sort of some mapping information in the DTO, and that would just return me an address entity, which I could then, and would persist it. All of that logic should be shuffled away from your controller. So the only other thing you might then have after this would be catch a validation exception and then return your response. That's it. Your controller is now 4 lines of code. Great. And it also means when you're adding new endpoints, it's really, really simple. All you have to do is create a DTO. So let's have a look at what that param converter might look like. I'm going to put all of my slides actually have already been posted on Twitter. They posted on Twitter on like the first couple of minutes of my talk. So if any of you want to look at the code and stuff afterwards, feel free. It theoretically should all work, because I took it from live application. If it doesn't, let me know, and I will fix that bug in my company's code, and then I'll help you out as well. So here we just have this method apply. Which is where you're essentially converting, it gives you the request object, and you can then create this extra object that you're passing in the param converter. So in this particular instance, this would work for any DTO. You'd have like an interface that all your DTOs would extend, and you'd specify that in your supports method later on. So what we're doing here is actually quite simple if you've used a serializer component before. We denormalize the data that's within that JSON blob, which is in the content of our message from just up here. We find out what class we're actually trying to create. So in this case, an address create DTO. And then we denormalize it, which essentially means grab all of the JSON data and populate that into the properties in this object. So I can now pass around this DTO object, which I know has these particular methods, particular properties, sorry. And then set that, return true. Super simple. And as I said, you can go and grab this code afterwards if you want. And your DTOs are just properties, so I haven't included that. I hope you all know what a class looks like. So that's DTOs. Validation. So a lot of people do validation, and they'll do like is valid in their controllers. That's not great. And I know the Symfony docs actually encourage this, but that's because they're trying to be simple. We're trying to go a bit further in this talk. Your validation should all be exceptions. And you should be able to throw a validation exception from any point in your application. You should be perhaps catching that in your controller. But you also could not catch it in your controller and just simply have your error handler handle it on a global level. You saw, and I didn't really mention it earlier when we were looking at those exception classes, there were little bits for the validation exception. So it could catch that, and it would bubble it all the way up, and then be handled by Symfony. So you wouldn't even need to mention validation exceptions in your controllers. So use exceptions. They are exceptional cases. If some kind of validation has gone wrong, if you're trying to put wrong data into the database or into an object, then say, hey, something's not right here, which is exactly what an exception is for. It's an exception. Use them. Remove that control from the controllers. Don't do is valid. Do it at a lower level. That should be in your services. Your controllers should be really small. So I mentioned we'd have a look at a full controller here. So we've got that line I mentioned earlier, map and persist. We've got our param converter generating a DTO for us really nice and neatly. Here we are catching the validation exception in the controller. It's nice to be explicit and to do that. But what we're actually doing is returning a validation error response. That's just a custom class that you might have defined. But if I left that, theoretically, it should be caught by my error handler anyway. And then what I'm doing here is, so created is just a nice little helper method that returns a 201 response. Address item is what the name of the root is. And then I pass through the actual content, which is just the ID. Simple. That's all my controller is in order to be able to create something that creates addresses. It's nice. And quick to add more, which is really important in REST APIs, because when they get huge, you want it to be really simple to add new CRUD tasks. Who likes spending time on CRUD? Yeah, that's what I thought. Formatting your output. So obviously, in a REST API, eventually you need to spit something back out to a user. And you can use a Symfony serializer component to do this. You can also, if you're doing JSON, for example, you can just say return new JSON response or XML response. That's a really nice sort of simple way to just go about it and just get it to sort of just do its business. But then what you have to worry about is you have to do, in the same way that we were just talking about mapping the request to the entity with that DTO in sort of in the meantime, in the middle, we should really have something between the database and the user, because we might not want to give them every single field. We might want to manipulate it. We might want to change the format of a date, for example. It might be stored as a Unix timestamp in the database, but we want to give it out to the user as ISO 8621. Is that right? I think I got the number wrong. OK, someone's trying to give me a hint, but I'm not getting it. Oh, well. I don't know my ISOs, apparently. And so what you put in here is not DTOs, something called transformers. Who uses transformers? OK, a few of you. So transformers, and if you think actually back to earlier when we were talking about the principles of REST, one of the things that I pointed out is that actually the important thing is that only your API, the server side of the API should be caring about the database. And you have this client-server relationship. So you need to, this is why it's important that you're not just dumping the database out. So this transformers part is kind of solving that part of REST, I guess. Transformers, and I'll show you an example in a minute, basically say, these are my field names. So I want ID, I want created at, I want first name, and then it maps to this piece of data. So you then might have ID, and then you might have address as a variable, and then get ID method on that, for example. We'll have a look at one of them in a minute. And a really nice library for managing all your transformers for you is called Fractal. It's by the League of Extraordinary Packages, which is, their name is supposed to be a joke if you don't know kind of the vendor already, but they do a whole load of really high quality packages. And Fractal is just a way to sort of manage all your transformers. So this is what a transformer looks like. There's a method on it called transform. You pass in an object, and you always pass in one object into this, although I'll show you in a minute, it can actually handle an array, and it will just do all the magic, or a collection, and it will handle all the magic for you. And you also have available includes. So for example, let's say that you have like another method down here, and on your API you want to say, I also want to include details from these particular relationships. So you're looking at a user, I want to also include details about their groups. And then you can have extra methods to say, OK, this is what it would look like if I was adding on the groups. This is what it would look like if I was adding on the country details or something like that. So as you can see, we're just sort of doing ID and then just grabbing it. So this is quite a simple transformer. But actually, on my address object in the database, you'll notice sort of I might have extra fields. I might have created at. I might have a phone number. I might have names. There's actually, I know for a fact that there's another field called created at in this instance. And also, I'm doing a little bit of magic here to sort of being able to return null. And I'm also getting it as a timestamp instead of just being able to, instead of just like throwing out the raw value from the database. So how can I interact with Fractal? Super simple, actually. So in the first example here, we're passing in a single item. We're just creating that resource, a single book. And in the second one, we're grabbing a collection of books. So then it would automatically basically have an array or a list of all of the individual books in that books array. And it would transform each of those individual entities for me, but in an efficient way. Then what we do is we can do a whole bunch of stuff with this at this point. We can put it in an array. We can put it into JSON. You can get it to format things for you so that it will have like data, and then it will have all of the actual piece of information, or you could just have all the piece of information from the array at the top level. I'd recommend you just go and sort of have a play and sort of do the different things, because again, it depends on how you want to format your API and how your documentation works with that. The other reason Fractal is really nice is that it ties nicely into my next thing that I want to talk about, which is pagination and links. So if we think back earlier, that's again one of our principles of REST. Hate OOS. Nobody likes pagination. Who likes pagination? Maybe someone prove me wrong. I like being wrong. OK. No, nobody likes pagination. It's not fun. But you have to do it if you want to have a REST API. And I say that in that you have to do it if you want to have a fully REST API, But it's also perfectly fine to say you don't have a REST API and you just do things your own way. So pagination to-do list. Like, I want to add pagination to my application. What do I need? First of all, you need to do it. You need to get over the hurdle of, oh, OK, I've actually got to handle this. I can't just spit out every single entity when they run get users. Really annoying. You need to make sure that you're linking to your previous page and your next page. Again, we're talking about hypermedia. That's a really important part of REST. You need to have links. You need to say what current page you're currently on. Even if you've given it back in your request, you need to say what it's on. It's really useful, particularly if you just keep iterating through the links to know kind of what page you're currently on. And you need to detail the total number of pages. That's really helpful for knowing, OK, I need to iterate for over 5 pages if I'm going to get the full set. However, that last one, something that I've noticed, particularly with working with a lot larger amounts of data, sometimes the most expensive part of an API request can actually be the count. So disabling a total can make things quicker. And it's probably the least important part of pagination, in my opinion. So if you're noticing a significant performance difference, and the way we handle this is we just added a query string parameter that says disable total. So for example, the front end didn't care if there was 10 pages or 100 pages, but it cared about the ability to go next. Then we would disable it would say, I don't care about the total, and disable it. And the endpoint would perform a lot faster. So just a little tip there. So what can we use for pagination? There are kind of 2 libraries that work quite nicely. Doctrine has a paginator. It can be quite inefficient. On a little plug here, actually, Sam knows is probably going to be open sourcing a paginator that works really well with a Doctrine ORM project that's a bit more efficient. But we're trying to PR it into Doctrine Paginator. But it's significant changes, so we'll see how that goes first. Doctrine Paginator, as I said, the main issue with it there is that to sort of be able to run, to do one query, just get one paginated page, it runs about 8 queries. Some of which are huge and have like 3 subqueries, and it does counts, and it does select alls, and all sorts of weird nonsense, particularly if you're doing counting. So just be careful of performance there. Make sure you're looking at the queries it's actually generating. And PagerFanta, which is also, again, a nice little library there. Go and have a fiddle with those 2, I would recommend. Both of which have fractal integration. So if we go back to this, and we're looking at our controllers again, what you can see here is I'm using findAllPaginated, which is just a repository method I created. We'll talk about that in a moment. And I return the paginator object, and this variable here is passed straight into Fractal. It can handle those paginator objects when it's creating a collection in exactly the same way that it can if you just pass it an array of objects. It will just detect that it's a paginator. And it will then also add in fields for things like generating links for routes. It will tell you what the current page is. It will tell you what the next page is, because it gets all of that detail, all of those details from the paginator. Great. And then at the bottom, I've just done it as an example with findAll. So as I said, you can see it's like a drop-in replacement, realistically, for Fractal there. So we've got a page number. I'm asking for page 5. How am I going to get that to my repository? How am I going to shuffle that through my application? You can do this, again. I like the param converter all the things. I've got this object here called user filters, which I pass into my findAllPaginated method. And we'll have a look at that in just a moment as to what that actually does. But essentially, one of the fields in there is the page number and the per page count. So sorts and filters, as you've just seen, there's an object for that. You don't want to pass around lists. You don't want to pass around scalar values. So if we look at a query string here, we've got our page number. We've got our number we want per page. We've got sorts, another thing that we kind of care about. We've got includes, which I mentioned earlier with Fractal. And I've also got a filter here, or a search. At the moment, I'm just kind of talking about filters, but searches are exactly the same. So again, I have my really simple controller passing everything in the param converter so that everything is done on a generic sense, and I can just whip out new controllers in 10 minutes to add new CRUD methods, because I don't like spending time on CRUD, and I'm lazy. Lazy developers are the best developers, because it means that you do this kind of stuff. What does this filters class actually look like? Essentially, it just has getters and setters, and you'd also have your properties defined there as well for get user, set user, and include a couple of traits. And these traits handle different things like pagination and sorting. Here, in this particular example, sorts would correlate directly to sort of the property names, which would be user and that kind of stuff. Again, there's a little bit of magic here, which I'm not showing you, which is the param converter. But I'm more than happy to share the code of that afterwards if you want. Then we have our find all paginated method. So again, looking at a repository here, we create a query builder for address. We add our filters. So you just run add filter for every single one of the filters you might possibly have. You run this add sorts method. And then you just create your paginator with those couple of things. So it's really easy to bring all of that data straight down to your repository. Those two helper methods that I just kind of talked about, I've put the code in here. Although I guess it's kind of, yeah, so for add sorts, it literally just says, OK, if there are any sorts that were mentioned in the request, add them as sorts, add them as order bys. And for filters, it says if it was specified as a filter and it wasn't specified to be sort of nulls, you need to work out how you're going to handle nulls and empty strings and all that kind of stuff, which is sort of here. Then basically add a where and set the parameter on that. So that's kind of what's going on there. Because for every single one of your filters, you want to define it generically, but you don't want a huge repository method which has loads and loads and loads of if statements, because it makes it look ugly, right? This is a much nicer repository method than having sort of 15 if statements. So finally, I just want to talk about a couple of tools. I'm a little bit tight on time. So there's a tool called API Platform. Who's used API Platform? Oh, great, most of you. It's really simple to use. Just run composer require API if you're using Flex. And it allows you to essentially generate all of your documentation for you. It will generate all of your routes for you. It will generate all of your method controllers for you. And basically produce a REST API. And all you have to really give it is your entities. I was going to do, if I had time, a small little demo. I'm not sure I do. So there's also the FOSS REST bundle. I've talked a lot about how to do these things yourself, which is great if you want to have a bit more control over what's going on. But the FOSS REST bundle can do a few of these things nicely for you as well. You can have it basically say that you want different error codes for different exceptions that are being bubbled up. And you can also say that you want different messages, so you actually want to throw the exception message. So you can just define that sort of in your config instead of having to define this controller method with the map that we saw earlier. It also adds a view layer. Essentially, you don't need to worry about things like format, like XML or JSON or anything like that. It will just do it itself. That's really useful if you're kind of not just doing a JSON API, but supporting it in multiple formats. Finally, it will do automatic routing for you. It will automatically create all of your routes. So if you have, you just define this in your routes.yaml file. You say it's REST, say the host and the resource, which is the controller. And then it will use the name of the methods to determine what the route should be. So this one is a get, and it's for users. So it would just do, it would call itself as the route name get users, and it would require the method get and do users. So it generates all of those routes for you, because adding routes is so much extra time in development. So just to quickly recap, we've got the principles of REST. We've got the uniform interface, which is all about being able to make sure that you've kind of what it actually looks like as a client and server and how you're interacting. It's got to be stateless, so you can't rely on sessions. It's got to be cacheable, or if it's not cacheable, you've got to explicitly say that it's not. You've got to have the client-server relationship. They have very different concerns. They shouldn't really be worrying about each other. And they need to be able to be developed completely independently of each other with just documentation in between. It should be able to be developed as a layered system where you've got, it doesn't know necessarily that it's talking to the API, it's talking directly to the database. And finally, the weird one, code on demand, just in case any of you are doing Java applets in 2018. Use HTTP well, use the HTTP verbs, use the response codes, and use those extra ones like 422 for validation. Don't just throw a 400. We talked about error handling and how you can use a controller to do that and just to override the default one. that's just disappeared one. Sorry about that. We talked about DTOs and the param converter. Param converter can save you a lot of messiness in your controller, which you'll end up copying and pasting anyway, and how we can use DTOs to map what you're getting as a request into essentially generating your entities and then maybe persisting as well. We talked about validation. Always throw an exception, catch it in your controllers. Don't run a is this valid in your controller. We talked about formatting output and using transformers and fractal. We talked about pagination, how much we dislike it and how much we need it. We talked about sorts and filters, filters also being able to be applicable to searches, and how we can pass that through as objects through our repository methods. And then finally, we talked about two different tools, the Phosphorus bundle and API platform. I hope that talk was useful to you and that you've taken something away. Thank you very much.